All right, guys, you guys were asking for a couple of videos on each of the different trainers that you're going to be working on. So I'll start here with the Burton trainer, then I'll do the whiteboards with the relays. I've also got to go over the timers for the Burton trainer as well. So I'll do separate videos. I'll put them on YouTube. They'll just be private so that you guys will have the link. Won't be any comments or anything there. So any questions or anything, you can just send me an email or ask your teacher in class. So the way that this class has been broken down at the moment is that I'm doing the theory um, prior to you guys going into the shop, and then your shop teacher is marking each of the projects. So my job is to try and make it as clear as possible as to what you're looking at on each of the boards and how to wire them up. So these guys are from a company called Burton Electrical Technical Incorporated. They're from a company close to Barrie, and they've created these awesome trainers in that all of your controls are 24 volts, and all the 2.8 is behind the plexiglass. So there's no way, unless you open up this cabinet, you can't come in contact with the 2.8. So much safer environment for learning. So what I'll do is I'll zoom in on each of the different components, and I may come back to this one to give you like a synopsis. But this is basically how your board should look before and after you're finished on the board or on the trainer. In that all your conductors are neatly put away. Everything's back into the tackle box here. So relays, timers, they're all back in here. This little control screwdriver, there's very few left in the class. They're not yours to take. They're there to stay for the next person, okay? So keep it there because we need a little control screwdriver just to reset the overload here. But a lot of you guys or previous classes have stolen this or borrowed it for the other projects. So if that control screwdriver is there, please leave it there. Very handy for resetting the overloads. And I'll go over how you do that in a little bit. So everything's gorgeous when you begin and when you leave, because we're not the only ones using this room. There's another class, like you guys are usually broken up into two classes, and we have the post-secondary and possibly night class that are using these guys as well. Okay, these are the ratings for this guy. So there's 2.8, 120 within the NEMA 1 box. Then we've got 2 amps for the entire unit, obviously 60 hertz. Interrupt rating is 5,000 amps. So you'll find that like relays and contactors and timers, they're only good for 5,000 amps of short circuit current. The starter coils are 24 volts AC. If you're doing this if I'm making this video for the advanced class, your boards are going to be 24 volts DC. But in the intermediate class, C546, everything's powered up with 24 volts AC. Okay. You have two different motors. So I purchased one block and another block. One of these motors was not available during COVID, so that might not match exactly with yours, but this motor is a 230 volt AC 3-phase, full load current of 1.2, nominal frequency of 60 hertz, RPM 1725. So that tells us that it's an 1800 frequency on the outside, 1725 on the rotor. So this is a 4-pole motor. Service factor, you guys will go over this in code. That's for your sizing of your overload, and it's only good for 1/3 of a horsepower. And this one is the enclosure is totally enclosed, non-ventilated. Okay, so let's move on to the next part. Keep this connected. So there's a twist lock 3-phase connector that's already connected for you. Keep it connected. So because if we take this in and out every class, then eventually this connector will fail. So keep that in there. You're more than welcome to put the wall wart onto the 120 as well. So there's a 120 to 24 volts transformer as well. Okay, they're shared with certain circuits. So if there was an issue, I'll show you like which fuse is going to blow. We have not had any of these circuits blow, but this is in the panel, and your instructor can reset one of these breakers if by chance one of them blows. But most likely it's going to be your control fuse. Okay, so this is your power supply. You got 120 volts coming in, and you got 24 volts AC coming out. Those are available here, so these guys are tied together. So 2 positives, 2 negatives to use. Try and make it so that you're doing your jumpers the same as you would with your wiring. So maximum of 2 jumpers or 2 cables on each connection there. Okay, and once you turn the power on is by putting the end connector of this, the 24 volts AC connector, into this guy right here. Once you put that in, it should illuminate this blue LED here. Okay, if it doesn't illuminate that blue LED, then this 3/4 amp fuse is blown. Do not, I repeat, do not put a larger fuse in there. Okay, otherwise we're going to be buying all kinds of new components. These 3/4 amp fuses are available at the teacher's desk at the front of the class. Okay, there's a 3-phase disconnect that then goes to this indicator here, so it'll show you that you have your 3-phase power from the shop, and then it also indicates on the actual fuses that you have that the fuses are good as well. We had an issue with some of the fuses during the COVID time. There was like a bad batch, and then we had too small of the fuses for when we go forward, reverse, so they were actually tripping. But everything should be good with your main fuses with these units. Okay, on the unit, we have, let's start over here. We've got a signal tower. We got a red, an amber, and a green light here. And we have a common for everything. There's also a buzzer that corresponds to this guy right here. So all of these guys have the same common. That common would be tied in with this guy. Okay, make sure that you actually put the load into the circuit. So put the light into the circuit. If you negate to put the load in and you just go from line to ground, smoking a pancake, you blow this fuse, this light does not come on, and then you're replacing that fuse. As soon as you replace that fuse the first time, you should be like, I totally missed the load and I'm not going to do that again during this course. So the maximum that you should be blowing the fuse is once, right? You're slowly and methodically going through your circuit. Usually the first time that you wire it up, you'll blow the fuse, but try to just blow the fuse once during the entire time that you're here. Okay, moving down, there's some float switches here. I should have a close-up of these guys. So they're actual float switches that you have to lift to change the state. They have a common, then a normally closed, and a normally open. Okay, so this one right here is an example of a Form C contact, where we have a common, normally closed, normally open. Okay, there's two float switches. This is your lower float switch. This is your higher float switch. Okay, then beside that we have two selector switches, one being just on and off, so two positions here. I don't actually know what the OX and the XO actually denotes. I've looked that up and I haven't been able to find that. I'll have to ask the guys from Burton what that actually means. So on-off controls right here. You can use that to control your timers and see how your timer works prior to wiring everything up. And then you'll have another project where you do hand, so manual control, off, and auto. So it's a 3-position switch. In the off position, nothing makes contact. In the hand position, you'll have to ring this out with an ohmmeter. I believe the top connections have continuity. And in the auto position, the bottom connections will have continuity. Okay, so use your ohmmeter and test this guy out prior to actually wiring up. We've got multiple stop starts here. So your stops are normally closed. Your starts are normally open. Okay, so multiple stop start stations. 8-pin timer and relay. So both the timer and the relay go into this base. So it's a standard 8-pin base there. We have found that some of the timers have failed already. I've had these trainers for about a year or two, and it's not the actual trainer, it's the timer from Schneider. The electronic components have failed. So if the timer is not working properly, call your instructor over. Maybe you should have 2 timers. So try out the other timer in your tackle box. If both of them are working, it's most likely that you're wiring. You can borrow one of your partner's timers, see if that fixes it. But it's most likely your wiring. It could possibly be the timer though, in that one of the timing functions, the on delay, the off delay, or the flashing is not working. Again, I'll do another video on the timer and all the different settings that are there. I think that covers everything for this portion of the trainer there. Main thing is to make sure that the load, being the coil 2 and 7, are actually in the circuit, right? So you've actually wired up the relay. You haven't gone from line to neutral, right? You're actually bringing in the light. So power up the light, power up the relay. Do not bypass those guys. If you blow the fuse, that means that you've bypassed the coil, or you've bypassed the light or the buzzer, and you just shorted from line to neutral. Okay, in the tackle box, everything is gorgeously organized here. 2 relays, 2 timers, with everything you need to know about the timers on the side here. We have a hasp here with a lockout tagout. there's most likely no fuses left from the previous classes. Again, these are available at the front of the room. You got a wall wart here to go from 120 to 24 volts AC. If this is still there, please leave it there. That's not yours to keep. And then over here, there's an MOV, metal oxide varistor. These are available if we had the mountings for them. So when the coils of the timer or the relay collapse, so you've energized the coil, created a magnetic field, then you de-energize that coil, that magnetic field is then going to collapse at a high rate of speed across the conductors of the actual coils. At that point, it's going to induce a large voltage, or a larger voltage than you want, and that voltage could migrate out and smoke something else within the circuit. So usually on the side of coils and contactors, we will have an MOV, a metal oxide varistor, and it just traps the energy from the collapsing magnetic field. We did not purchase the mounting for those guys, so that we have those MOVs there, but they are not part of the circuit. Okay, 8-pin wiring connections. So we've gone through this in the first class for sure. So two commons. This common number 1 is common to number 3 and number 4. Okay, number 4 is the normally closed. Number 3 is the normally open. Common to number 1. Okay, that is this guy right here. Right, so there's an armature that changes state as the coil is energized. So this is made of steel. The 24 volts is placed onto the coil. The armature pulls in towards that coil and then changes the state of the contacts there. Okay, so on the other side we have a common, number 8, and then 5 is our normally closed, and 6 is the normally open. Those being the shelf state. Like if you took it off the shelf and you took an ohm meter and you went between those two terminals, you would find continuity between 8 and number 5. You would not have continuity between 8 and 6 until you energize the coil. Coil is always 2 and 7. 2 being the feed, 7 being the neutral. Okay. Diagrams are also on the side of the relay. And on this unit from Schneider, it gives you the voltage. So right on the front of the unit, it'll tell you the voltage. There's a manual override. So you can override the coil, right, and turn the unit on, and you can change the state of the relay. Okay, there's a little pin right here, and that pin, you can't see it on this diagram, but if I go back to this guy, that pin would lodge right in there. So there's only one orientation that unit can go into the base there. Okay, moving on to the timer. If we're looking for the on delay, and again, I'll do another video on this one, but on delay for this guy is the A setting, right? It says that your timing is, you can go 0.1 seconds to 100 hours here. The wiring for this guy, you will find that 2 and 7 are the coil. And then we've got a set of contacts. We've got number 1 is a common, and then just the same as we had for the 8-pin relay, number 4 is the normally closed, number 3 is the normally open. Only one set of contacts on there. Aside from that, you'll find that pin number 6 is there for the off delay signal. So for the off delay portion of this guy, we actually have to send a signal into the unit rather than just turn the relay, the timer on. Okay, so A is going to be our on delay timer. So A means that we put power to the coil. So U is the power to the coil. As soon as we put power to the coil, then after some time, then the contacts are going to change state, meaning that it's going to go from a 0 to a 1, or from open to the closed state, right? So they're going to change state after I energize the coil. So that's A. The setting is right here, so you'll use the control screwdriver that you're leaving in the tackle box and not taking home. And you can just change the state of that guy from A is your on delay, and the timing of this guy is set here. So you got 10 different increments here, and then your actual timing for how long you want it to be will be right here. So we usually keep it on 1 to 10 seconds, and we leave it on like 5 seconds, because ain't nobody got time to wait longer than 5 seconds there. Okay. In addition to the on delay, we also have the off delay. I believe off delay is C. So the C state is that you put power to the coil. So you're maintaining power to the coil. And then Y1 is this signal right here. So we know we have to do two things. We have to put power to the coil, and we also have to send a signal into Y1, and Y1 is pin number 6. So as long as the timer is energized and we send a signal into pin number 6, then it will change state. Okay, but you will see that it changes state when the signal from Y1 comes in, right? So as soon as you change the state there, then the contacts change state right away. So ours are relay contacts. So they change state right away as soon as pin number 6 gets a signal. And then once pin number 6 loses that signal, so an off delay has to get a signal and then remove the signal. Then the timing or the magic happens before it goes back to its rest state. Okay, so one more time. On delay timer, you energize the coil. And a little bit of time after you energize the coil, then the relay contacts are going to change state. As soon as you de-energize the coil, then the relay contacts revert back to their rest state. That's an on delay for step A. C is an off delay. Off delay, you give power to the coil the entire time, and the thing that decides the timing is Y1. Y1 is the signal to pin number 6. We send a signal into pin number 6. Relay contacts change state right away. Okay, they remain in that state until pin 6 loses the signal. Once pin 6 loses the signal, then the timing happens, and eventually after that timing set with this guy, then the relay contacts will revert back to its rest state. So A is on delay, C is your off delay. Aside from that, we have a flashing timer, and I believe the flashing timer is DI. I could be wrong, but DI looks like the flashing timer. I think so. So I could be wrong. I'll do another video on this, but looking at it quickly here, looks like DI, so this setting right here, as soon as we put power to the coil, right, the coil is this guy right here, then once it's got power, then the relay contacts are going to change state, stay in that position, revert back to rest state. Same timing, change state. Then after that timing, revert back to rest state. So if you set this for 1 or 2 seconds, then flash on, flash off, flash on, flash off. So I believe there's one of those settings where like it gets to a high level and it wants to flash the light on and off to tell you that you're at that high level with the float switch. Okay, so I believe A, on delay, off delay is C, and I think the timer is DI, looking at it. Fairly confident it's DI. Okay, moving on. 8-pin relay we've already gone through. It's set up here where we've got 2 and 7 as the coil, right? 2 is your feed, 7 is your return. 1 is your common to both 3 and 4. 8 is your common to 5 and 6. Identical base for both the relays and the timers on your unit. Okay, as we're going through, I failed to mention, but don't write on these boards. They're not yours. They're mine. And I spent a disgusting amount of money on them, so please, no and that's or phallic symbols or writing on the board whatsoever, please. Okay, so any writing is going to be in your textbook and not on the units. Okay, we got a float switch as well. So we already mentioned that we have commons and normally open, normally closed, right? And then those guys correspond to these guys. So this contact right here, or right here, corresponds to the lower float switch. So you have to lift this guy up to change state, and then the higher float switch will correspond to these guys. Okay, we've already talked about the selector switch with the on-off, the hand-off auto switch as well we've already gone over. There are multiple stop-start stations as well. So they correspond to like a square D start-stop station. Stop is always a normally closed, and your start is always a normally open. As you're doing the wiring, if on the ladder diagram it shows coming in on the left-hand side and out on the right, then wire it the same way. It's much easier for troubleshooting later on. Okay, so an example of like 2 different stop-start stations would be on either end of a conveyor belt. You would have a stop-start on one side and a stop-start on the other side. And as we're going through these trainers, this one has 3 different terminals. So all the stops are in series and all the starts are in parallel. in order for this to be maintained or be a 3-wire circuit, we have a holding contact here that corresponds to the contactor or the relay that we're working with. Okay, overloads are in this diagram are mounted right here. Other places will show that the overloads are mounted right here. Doesn't really matter, it's a series circuit, it breaks the current in one place or another. The only beauty of having the overloads over on this point right here is that once the overload trips, then nothing gets power whatsoever. It's also not switching the neutral, it's switching the hot on the circuit there. But most of the textbooks will have the overloads right here. Okay, we have limit switches as well. So we have a normally closed limit switch and a normally open limit switch. Okay, so by changing the state of the limit switch in one direction or the other, so you have something moving on a conveyor, hits the limit switch, changes the state of the contacts, both these contacts will change state simultaneously when you move it to one direction or the other there. Okay, we also have a stop, a forward, and a reverse. Stop being normally closed, forward and reverse both being normally open. Okay, so you're going to be working through these guys later on with the forward reverse contactors. We're going to do the first 6 on the Burton Trainer, and then you're going to move over to the whiteboards because there's other guys working on the white relay boards. Up to number 6 in the Burton manual, you're basically kind of doing the same thing in that the Burton Trainer is giving you the diagrams. The whiteboard training is taking a written paragraph and changing it into a ladder diagram, but they're very similar on the outcomes that they're looking for. They're not actually wiring up coils and contactors and overloads, just relays, timers, lights, possibly a buzzer. Okay, this guy right here, the signal tower, again, has each of the individual lights. The buzzer is right here, and they share a common connection right there. Okay, when we get to the motor controls, then on the side, do I have the diagram there? No, I neglected to put that photo in there. But on the side of this unit, there's a whip that goes down to the motor. So make sure that it's actually connected to the side connector of the unit. Their first one is going to start off with a single contactor, single overload unit there with your main fuses here. Again, these fuses should be good. If there's an issue with the fuses, it will show you that it's blown, but I think that we've taken care of any issues with the main fusing on the units there. Okay, power is also available once you turn on this manual starter here, or disconnect. Okay, everything in this box has been brought out, so anything that you need to wire up, so the coil is A1 and A2. On this unit we have a normally open and we have a normally closed. So those guys are here, auxiliary, normally open, normally closed. And then these overload contacts are down here. The normally open is right here, 97, 98, and the normally closed, which we're making use of on the previous diagram, right here. This normally closed right here is 95 and 96. 2 seconds. I'm going backwards, donkey. Apologies. There. Okay, so 95 and 96 is the normally closed. They correspond to these guys right here. If you go forward, reverse, forward, reverse, forward, reverse, then these guys also, so the overload looks for too much current going to the motor windings. It will also have phase loss detection, and supposedly when you go from forward to reverse, it sees a loss of one of the phases, so it may trip out if you continuously go forward, reverse, forward, reverse, forward, reverse, forward, reverse. You're sending an inrush of current to the motor. So unless you want to purchase the motor that's at your trainer, then just do forward, reverse, forward, reverse, and you're good to go. Call me over or call your instructor over and we'll show you and we'll see that everything's working. Okay, don't increase the values on the overloads. They're already set for those motors. Okay, if you go forward, reverse, forward, reverse, forward, reverse, eventually the overload will trip or the mains will trip here, but most likely it'll be the overload. If it does trip, you'll see a T right here, and so you'll have to hit the blue, I think it's blue, the blue button there in order to reset the overload. In order to test the tripping of the overload, you can take your slot screwdriver, being very careful because you have energized 208 in this box, and you can slide this over to the side or have your instructor slide over the side to demonstrate an overload condition. Usually on the overloads, we're going to have this fault light turn on. Okay. In addition to that, we got a run, stop, and fault lights here as well. Okay. All sharing the same common back to the 24 volts controls. Okay, this gives you like a better view of what's in there. So A1, A2 is the coil. We got normally closed contacts, normally open contacts. If there were additional contacts to go on here, then this window here would be removed and they would be auxiliary contacts that would slide on top here. You can change the state of this contactor by using the control screwdriver and pushing this in. That will allow the current to go from line 1, line 2, line 3 down to T1, T2, and T3. So you can manually start the motor by pushing those guys in. Okay, the overload is set here. You're not cranking the current on this unit. This is a variable unit in that this overload unit is good from looks like 0.3, sorry, 0.63. I can't make that out to 1 amp there. So there'll be a range in which the overload will trip. In addition to that, we just have a number of terminal blocks right here and your main fuses. Okay, those main fuses should be good now. We had some issues with them, but I believe each of those guys are fine. These guys are expensive. They're like at least 15 bucks each. So we definitely wanted to make sure that that was taken care of. And again, if you go forward, reverse, forward, reverse, forward, reverse, you may cause too much current to go to the motor, and you may actually trip these fuses here. Okay, on the back of the lights, we've got all the terminals here. And then there's a capacitor there as well on the coil. So on A1 and A2, there's a capacitor that's placed there. And so that when the magnetic field of the coil collapses, it doesn't backfeed and smoke something else. It just charges up this capacitor. So this allows the energy from the coil to be held within that circuit and doesn't migrate out to smoke something else connected onto the distribution panel. On top of that first box, there are some faults. So your instructor may be switching these guys and you're going to have to troubleshoot them. Otherwise, your instructor will come up with their own novel faults that they'll put onto your control board. Don't put faults on your buddy's board. You really have no idea what you're doing, and you're probably going to short out the supplies or blow fuses or something like that. And they're too expensive to, the actual trainers are way too expensive to replace. So leave it for your instructor to put the faults on there. Okay, so we've already gone through this with all the different contacts there. If needed, I can put this PowerPoint available as well as the video. Okay, the overload ties into T1, T2, and T3 right here. So when you tighten these guys down, then as soon as these are tight, then they're going to be grabbing onto the copper bus bars of the overload here. This overload is good from 23 to 32 amps. So you can see that you definitely want to make sure that you have the right rating. If we put this onto our motor that's only good for like 1 or 2 amps, then smoking a pancake. Okay, the testing will be moving this guy to the side. Reset will be this blue unit right here. Okay, in the next box, we have a double contactor. So we have forward and reverse. So each coil has A1 and A2. So they are right here, A1 and A2 for the forward, A1 and A2 for the reverse. And then they have a set of normally open, normally closed contacts. And it looks like they have 2 sets there, 53 and 54. Maybe there's additional contacts on the front there. I just grabbed this from the internet, but there must be additional contacts on the front. Hopefully you'll see that in the next slide there. Again, if you wanted to manually turn these guys on, you would open up this window here and you can push on the actual thing that pushes into the contacts to close these guys. So you can manually push there and that will close the forward, or you can push here and that will close the reverse. There is a pin though between the forward and the reverse. We'll go through this in detail. You do not want both sides turning on. Otherwise, line 1 and line 3 fuses will blow. And this one's only good for 5,000 amps. When you blow line 1 to line 3, you're going to have a minimum of 10 to 15,000 amps. So this could rupture and vaporize in your face. So there's a pin between the two that stops the forward and the reverse from turning on at the same time. Okay, in addition to that, there's also a set of overloads there. So normally open and normally closed contacts are here. Normally closed is used to break contact to the rest of the circuit. This normally open would be to send a signal to the fault light to say that there's a fault if the overload is tripped. Okay, so here we have the forward and reverse, and remember what I said where there was looked like there was additional contacts here? Well, if we look at this guy, there are additional contacts on the front face. So they've removed that plastic window, they've slid this unit in, and this gives us an additional normally open and additional normally closed for both the forward and the reverse contactor. For forward reverse, they only need to make use of one overload because the contacts either go from line 1 to T1, line 2 to T2, line 3 to T3, or they go from line 1 through this guy, so that would actually be line 1 over to line 3 to line 1, and line 2 stays the same in this guy. So forward and reverse only need one overload unit. So the fusing is going to give us our overcurrent, and the overload is going to give us our overload protection. Overload meaning that we're just pushing too much current towards the windings of the motor. This doesn't protect against short circuit, it just protects against overload. Okay, you can see that the jumpers on the forward reverse are done on the top and the bottom as well. So there's no need for us to wire the forward reverse contactors in. They already use these bus bars that are there. So jumpers here and jumpers on the bottom as well. As you can see, the additional jumpers on the bottom to reverse your line 1 and line 3 connections on this contactor, keeping line 2 the same. Okay, there's that wiring harness, so make sure that it's actually connected to the box that you're wiring to, otherwise your motor won't turn on. And make sure that this is connected and disconnected without any load on. So you don't want to be sending current to the motor and then disconnect it. It's not used for switching capability. Okay, this is one of the motors that we have in the shop here. So it is a 4-pole motor, like we said. The speed is 1725. It's got a service factor of 1.0. It's got a frequency of 60 hertz. And it looks like if you were to use this with a drive, then different frequencies would have different horsepowers and different RPMs there. But this one is used as a 4-pole motor with 2.8 as the supply. And that covers everything on the trainer. So hopefully I've gone over everything that we need to know on this trainer. I'll just flip back to the beginning there. You guys will tell me in class whether I've done a decent enough job on going through all the components and you feel confident about wiring these guys up. All the diagrams are provided in your manual. Some of your diagrams are missing components, so you're going to have to fill in the blanks there. Your instructor will have the answers. They have a binder that they're carrying or that's in a closet in the classroom. So once you figure it out, then go to your instructor, say, all right, I'm ready to be marked. Or like if you're stuck on something, say like, this is my understanding of the circuit and the components that are missing there. Does that jibe with the answer sheet? So I'll leave it there, guys. Hopefully I've covered everything. Let me know if I've missed any key components, and I'll redo the recording. Next video I'm going to do is on the timer and these settings. Where's that timer setting? These settings. So I got to make sure that this is actually the flasher, and then I got to go over the basics on an on delay and an off delay timer. And I think I'll do that in the classroom. In that I'll kind of put two portions together. I'll do a little bit of video at home, then I'll show you in the shop sending a signal to the coil, and you'll see the way that an on delay versus an off delay timer works. All right, guys, I'll leave it there. See you guys in class.